Okay, so now we're going to investigate a little more about the derivative graphically and numerically, what's going on here. Um, so far, understanding the derivative is that it represents the slope of the tangent line drawn to the curve at a certain point. We're going to complete this table below as an investigation, estimating the value of the derivative at the indicated x values by drawing a tangent line and estimating the slope. So if we look at the x value of -7, the estimation of the derivative, just by looking at the graph, we're going to say at -7, 1, 2, 3, 4, 5, 6, 7. If I draw this line, it looks like it's going to be something like that. That has a slope of about 4, I'm going to say. Is the function increasing, decreasing, or a relative max or min at that point? So at this point of tangency, the function itself is going upwards. So we're going to say that the function is increasing. Equation of the tangent line at this value of x. Well, we know that the derivative, if we're estimating it to be 4, our point of tangency is -7, -3. Our slope of our tangent line is, we're saying, approximately 4. So if we write the equation, it's going to be y plus 3 equals 4 times x plus 7. All right, now at -6, if we do that, actually we're going to skip -6 because we're going to kind of find the same thing going on here, again in the interest of time. At -4, we're up here, we draw our tangent line. I'm going to estimate that slope at -4 to be about 0, the slope of that line. The function actually has a relative max. It's neither increasing nor decreasing right up here at the top. Right, I'll do it in green so we can see it. The function's at a relative maximum. It's the maximum in its little area locally, right? And if we find the slope of the tangent line, we're going to say that the point of tangency equals, we were at -4. And the y value looked to be 2. And then the slope of the tangent line is 0 based on what we saw on the graph. That was our estimation. So our equation of the tangent line is going to be y minus 2 equals 0 times x plus 4. So that whole right side equals 0. So that would be y equals 2 is what we're going to come up with. All right, so then if let's pick a x value somewhere between here. We're not going to do both. We'll do this one, -1. If I draw my tangent line there, the slope of that line, if I'm estimating it at -1, looks to be about, say, -2. I'll use I'm writing in the wrong spot. The derivative of -1 looks to be about -2. What's happening with the function at that point? The function's decreasing as I go from left to right. We don't need to do every point to see the pattern. The point of tangency is going to be 1, -4, and the slope of the tangent line, sorry, it's not 1, -4, is it? I'm at -1. I was at the wrong place. It looks like the point of tangency at -1 is going to be -1. Yeah, sorry. I was at the wrong point. And then the slope of the tangent line is, we estimated it to be about -2. So if we write the equation of the tangent line, we're going to get y plus 1 equals the slope times x minus 1. All right, so then let's pick another point here. If we draw in our tangent line, estimated slope of 0. That's the bell for the end of the day, so we'll hear some announcements. We'll ignore those. That is at an x value of 1. So if I do the derivative, if I estimate the derivative at 1, it's about 0. The function at that point has a relative min. Okay, so the point of tangency there is going to be 1, and that's the one that I thought was -4. I was ahead of myself. Slope of the tangent line is about 0. So if we write the equation of the tangent line, we're going to get y plus 4 equals 0 times x minus 1. This whole right side of the equal sign equals 0, so it's going to be y equals -4. That's really the slope of our tangent line. I'm circling that one just to you know, these are the answers here to the slope of the tangent line, but I want that one to stick out just because I solved it. Let's go to a 1 on the next interval, so there is only one choice. If I draw my tangent line here, that's at the x value of 3. I don't know, I'll draw it kind of, it looks to be kind of like that. Again, I know it hits more than once, it's kind of hard to draw, but I'm going to say that that slope looks to be about 3. So the derivative at 3 is about 3. So then if I look at the function at 3, the function here is going up, so it's increasing. So if I do the point of tangency, here is going to be 3, it looks like -1. The slope of the tangent line we said was about 3. So our equation is going to be y plus 1 equals 3 times x minus 3. If we move on and go to the top up here, we draw our tangent line. That's going to be 0. So the derivative at 5 looks to be about 0. That's the slope of the tangent line is what it means. The relative maximum is what occurs there. The function is neither increasing nor decreasing. Our point of tangency is 5, 4. Our slope of our tangent line is equal to 0. So it's just going to be y equals 4 because I know it's going to pass through the y value, right? So it's just y equals 4. Then on the last one, if I draw my tangent line and estimate it, I think we get the point. I don't need to do that. What's going to happen is because the slope is negative, we know the function's actually decreasing, and that's going to make sense for us. So based on what we observed from this table, if we're looking for patterns, and again, I can come back to this graph to investigate. I like the sine because it's got lots of these intervals going on here. I've got sine of x. Based on these intervals, if I'm at a point where if I go from left to right, the function's increasing, notice the slope of the tangent line's positive on this interval. Once I switch over to decreasing, then the slope of the tangent lines become negative. And then when I switch back to increasing, so that's what we've noticed. So based on what we observed here, what do we notice? And these are all going to be important things. Number 1, if the derivative at a specific x value is positive, then the graph of f of x is increasing at x equals a. Vice versa, right? I'm not going to write it out for you. I'll just say 2. That's a terrible v. Vice versa. Trying to save some time here. 3. If f of x has a relative maximum, or I should say not if, sorry. F of x has a relative maximum if the derivative at that specific x value is equal to 0 and the derivative changes from positive to negative. Okay, and then number 4, we're going to say f of x has a relative minimum if the derivative at that specific value equals 0 and vice versa. All right, so that means that it's going to have to switch from, the derivative is going to switch from negative to positive. Let's look at what we do numerically. The value of the derivative can be estimated by finding the slope of the secant line passing through 2 points on either side of that point. And we want to take the closest ones, of course. So like if, let's do our estimation of a derivative. If we want to estimate the derivative at 0, since we have a table of values, we'd have to know the graph is continuous, by the way. But I want to estimate the derivative or the slope of the tangent line at 0. What I'm going to do is I'm going to use the 2 points on either side of it, calculate the slope of that secant line, and that slope of that secant line will be a good estimate for the slope of our tangent line. So the derivative at 0 is going to be about, if I do my y minus my y over my x minus my x, so it's going to be about negative 5/4. So we can estimate our derivative there at 0 to be negative 5/4. And what does that mean about the function? Well, what we learned before is if we know the slope of the tangent line is negative, then we know that f of x itself must be decreasing. Okay? The equation of the tangent line, we can come up with one since we have an estimate for a derivative. The point of tangency here is 0, 1, because we have our point here. And the slope of the tangent line was estimated to be negative 5/4. So my equation could be y minus 1 equals negative 5/4 times x minus 0. So we're going to complete this table for all of those x values using the table above. So if I want to estimate the derivative at 1, I'm going to use the points closest to it on either side and find, what I'm really finding is the slope of the secant line and using that as an estimate. So we're not going to do all of these. If you want to pause the video and get to practice, you can. So if you do pause it, here's what the answers are that you would get. We would get about negative 1/4. Since my derivative is negative, that means the function's decreasing, and our line, when we work it out, should have come out to be that. At 4, I'm getting about negative 4/5 for our estimate when we do the slope of the secant line. Since our estimation of the derivative at 4 is negative, that means the function will be decreasing at 4. And our tangent line would be y minus 0 equals negative 4/5 times x minus 4. At 6, our estimated derivative would be 1/3 by finding the slope of the secant line using the points on either side. Since that's positive, a positive slope, that means the function at 6 would be increasing. So really the sign of f prime of c tells us about the graph of f of x at x equals c. So that's important to note. This last one, the tangent line would be y plus 7 equals 1/3 times x minus 6 based on our estimate of the slopes. All right? So here we have a graph of the function g. And based on this graph, we want to make inferences about the derivative. So the inference we want to see, we want to find out here is, on what intervals, where is the derivative negative? Well, we know the derivative is negative anytime the graph is going down or decreasing. So that's going to be between this relative maximum and this relative minimum, and then again from this relative maximum down forever as x keeps going to infinity. So we're going to say that g prime of x is less than 0 on, and we'll write those two intervals. We're using our x values, right? Negative 4 to negative 2. Union also from 1 to infinity, because here's our explanation piece that we have to do in calc. The graph of g of x is decreasing. All right, now we want the intervals where it's positive. So of course, that's anywhere f is increasing from left to right. So that's from negative infinity up to the x value negative 4, right? We're looking at our x values when we're talking intervals. And then again from this minimum to this relative maximum, so over this interval. So these intervals are from negative infinity, it stops at negative 4, and then goes from negative 2 and stops at 2. Oh, sorry, at 1. Stops at 1. I went too far with my purple shading here. So it's on this part of the x-axis. Okay, so we're going to say that g prime of x is positive on negative infinity to negative 4, union negative 2 to 1, because the graph of g of x is increasing. Okay, then we want to find where are the values of x where the derivative is equal to 0. So let's do those in green. We already did green. Let's do those in white. So that's going to be, we're going to say that g prime of x is equal to 0 when x equals, it's not intervals, it's actually just at specific points, x equals -4, -2, and 1. That's because these are the relative extremas, the maximums and the minimums, where my tangent lines will go horizontal. And we'll say because g of x has a relative maximum or minimum, which I could just say extrema, covers both of those. Okay? Sometimes we're asked to find the normal line to a curve. So normal means it's perpendicular to something. So it's going to be perpendicular to our tangent line. So we have a graph pictured here to the right. Draw the tangent line at x equals 1. So we'll draw our estimate of it there. There's our tangent line. There's our point of tangency. There's our tangent line. Then in green, okay, we're just going to find out some stuff about the tangent line first. Sorry. So the tangent line, we're going to estimate its slope, because when it says to estimate the derivative and we have a graph, we can just estimate the slope of that line. It looks like it's about -2, I'll call it. Find the equation of the tangent line to the graph. So we want to write the equation there. So we need the point of tangency. That's going to be if I plug 1 into the equation, or I could look off the graph. It's going to be 2. So 1, 2 is our point of tangency. Our slope of our tangent line, we said, was -2. We estimated it at. So the equation, the equation of the tangent line, I want to write it in point slope form, is y minus 2 equals the slope times x minus 1. That's our equation of the tangent line. Now, a normal line is the line that would be perpendicular to our tangent line. So I'll draw that in green. It passes through the point of tangency. So it's the line that's perpendicular to our tangent line at the point of tangency. And now they want us to write the equation of the tangent line. So I know that the slope of the tangent line is about -2. So then we know that the slope of the normal line is really 1/2, because we know perpendicular lines have opposite reciprocal slopes. The point that it passes through is that point of tangency. So now I can write the equation as y minus 2 equals 1/2 times x minus 1. Okay, moving along. We've got a little bit of practice on the back here of writing down and evaluating some of this stuff here, like making conclusions. So the graph of the derivative is pictured below. So we're kind of going backwards now. Identify the following characteristics about h and give reasons for our responses. So when is h increasing? Well, we know that h would be increasing anytime its derivative is positive. Since this is a graph of h prime of x, the derivative, the spots where it's positive, I'm going to trace in green. So I'm tracing the spots where the derivative is positive in green. Are there any spots where it's above the x-axis? So the intervals on which that occurs are between -2 to 1. I like to trace them on the x-axis, and from 3 to infinity. So we're going to say that, how do we want to say this? They want to know the intervals where h of x is increasing. So we're going to say h of x is increasing on the interval -2 to 1, union 3 to infinity, because h prime of x is positive. We can say because, maybe I don't want to say it that way, but I'll just leave it like this for now. Because its graph is above the x-axis. I shouldn't say it's, by the way, here. Because the graph of f prime of x, no pronouns, is above the x-axis. I probably could have said that better. I could have said you know, h of x is increasing on these intervals because the graph of f prime of x is above the x-axis, which makes it positive. Or again, I can't use the pronouns, which means h prime of x is positive. All right, so the intervals on which h of x is decreasing, that's going to be anywhere the derivative, I'll trace that, white's not going to work, in orange, anywhere the derivative is negative, so it's going to be on these intervals from negative infinity to 2 and from 1 to 3. So I don't need to kind of write that out. You know how you can write out the reasoning here. We have the proper intervals. We're going to say that h is decreasing on those intervals because the derivative is below the x-axis, or because the graph of the derivative is below the x-axis, which makes the derivative negative. Let's talk about relative minimum. So a relative minimum is going to be anywhere where the derivative is 0. So I will do those in white. And so it's not just those points. And the derivative has to switch from positive to negative or negative to positive. So those are the possible spots. Now I got to check if it switches. Well, at -2 it does switch. So we're going to say, and it switches, the derivative switches from I shouldn't say it. The derivative switches from negative to positive. So that means that we're going to have a relative minimum there. Because if my function was going down and then turns around and goes up, that's a minimum. Then over here at 1, the derivative switches from positive to negative, so that's going to be a maximum. So h of x has a relative maximum because h prime of x is equal to 0 and it switches, and h prime of x switches from positive to negative on the graph. On the graph of h prime. Something like that. So wherever it has a relative minimum is going to be at -2 and at 3 because f prime of x, or sorry, h prime of x is equal to 0 and h prime of x switches from negative to positive. So these two, we're going to say if h of -1 equals 1/2, what is the equation of the tangent line drawn to the graph of h at x equals -1? So I want to write the equation. I know my point of tangency is going to be -1, sorry, 1/2. They give that to me here. And then my slope of the tangent line, I have to go to my graph and get that. When x equals -1, I'm up here on the graph at 5. So that means that f of -1, f prime of -1 equals 5. So the y value on the derivative actually represents the slope of the tangent line. So I can say y minus 1/2 equals 5 times x plus 1. If h of 2 equals -3, so my point of tangency is going to be 2, -3. Write the equation of the normal line. So I know the slope of the tangent line. If I go to 2 on this graph, the y value at 2 is -2. So the slope of the tangent line is -2. So the slope, I'll write it out, slope of the normal line is the opposite reciprocal, which is 1/2. So the equation of the normal line is going to be y plus 3 equals 1/2 times x minus 2.